right, so some random questions are coming up here. So the first one here, question one, if I give you a line and I tell you that this is 30 degrees, I want you to tell me what the value of x is and y. Y is this angle, x is that angle. And that's a straight line over there. Question number two, if I have a rectangle and I ask you to find for me if this is 0.25, those two sides are equal, and this is 0.15, see if you can get the perimeter and the area for this one. Perimeter and area. And it's in centimeters. Okay, question three. Without a calculator, see if you can find for me what is 25% of 2,876. If you can, let me know. Maybe you need a calculator. You can double check that one. Try it without a calculator first. Next one. Find the lowest common multiple and highest common factor of 16 and 64. So get me the LCM and the HCF. Press pause, give it a try. Press play when you're done. All right, let's have a look at this now. So in the first question here, you got question one. It's a straight line. Remember, angles on a straight line add up to 180 degrees. So for this one here, in order to get x, this number plus 30 must equal 180 because angles on a straight line add up to 180, right? X is going to equal 150 degrees, okay? Because 150 plus 30 is 180. And this angle here has to be 180 degrees because it's a straight line, right? And together, it'll add up to 360, which is a revolution. Okay. The next one, the perimeter. Remember, if this is 0.25 and this is 0.15, this is also going to be 0.25 centimeters over here, and this is going to be 0.15 centimeters over here. Now let's find the perimeter. Perimeter, we're going to add it all up. So 0.25 plus 0.25. I can just times it by 2, right? Because there's two of them. So I'm just going to times it by 2. I'm just going to write it a little higher. So I'm going to go 0.25 times 2 plus 0.15 times 2. And this will become 0.5 plus 0.3. And that will become 0.8. Cool. That's going to be 0.8. Don't forget its perimeter, which will be centimeters. Let's double check it. At 0.5, 0.3, 0.8. All right, this one over here, 2 marks. If you gave reasons for this one over here, remember this reason is angles on a straight line. Equals 180 degrees. And that would be another mark. So that could be 2 or 3 marks, right? This one here, area now. Area we multiply length times width. This length multiplied by that length. Okay? So that's going to be 0.25 times by 0.15. Okay. You can also, if you don't use a calculator, you can convert it into 25 over 100 multiplied by 15 over 100, and then take 25 times 15. So 0.25 multiplied by 0.15 comes to 0.0375. And that's your area in centimeters squared. Centimeters squared. When you're working on a percentage, you put 25 over 100. Let me just get the mark allocation here. So 1 mark, 2 marks. This one's also 2 marks. So this is 4 marks. You lose 1 mark if you did not put the sign. If you didn't put centimeters squared, I mean the unit, centimeters or centimeters squared, you lose a mark there, right? So if you have units in here, it'll be -1. So no units, -1. 25% is 25 over 100. Off is always times. And 2876 over 1. That's the calculation we can't show without a calculator. We can then simplify this by dividing this by 2, or just simplifying this whole fraction. This becomes 4, right? This will become 2876 over 4, which is basically, if I take 4 on the outside of 2876, 4 goes into 2, it can't. 4 goes into 28, 7 times. 4 goes into 7, once, remainder 3. 4 goes into 36, 9 times. So that becomes 719. The lowest common multiple is the number. Remember, multiple start. So you'll have starts from the number, and then you just keep working your way upwards, right? 16 plus 16 plus 16 plus 16 plus 16, etc. And you can see there's a common multiple, which is 64. So the lowest common multiple will be 64 because multiples of 64 start with 64. And then the highest common factor is numbers that can divide into both. What's the highest number that can divide into both? If I look at it, I can divide this number by 16, and I can divide this number by 16, and there's no bigger number that I can divide into both. So 16 is the answer. All right, let's go on to the next page now. Okay, I've got a circle in the first question. In the second question, I've got a circle, but I've also got a shaded area. Next one, I've got a cylinder. And the next one will end up as a sector, and I'll draw it in a sec. This one's going to have a sector in it. So let's go to the first one. This is question number 5. Okay, question 5. This is 4 centimeters. I need to know what is the area, and I need to know what is the circumference. Next question. I'm told that this inner value over here is 8 centimeters. And I'm also told that the radius running across all the way outwards is 6 centimeters. Okay. And the radius going outwards, 6 centimeters per minute. For this question here, they want you to calculate the area of the unshaded region, the unshaded part. And we have a cylinder, supposed to be a cylinder. I'm told this is the diameter here, this is the diameter here. This is 20 meters, and this is 20 meters, and the total height of this is given as 20 meters. I want to calculate for this one here, get me the volume and the volume. And I also want to calculate the surface area. Alright, next one is the sector. This is the center. This is 8 centimeters. And this is 8 centimeters. And I'm told that this angle over here is 150 degrees. I need to calculate the area. And I also need to calculate the perimeter as well. Okay, this one here is 4/5 marks. This one here, also 4/5 marks. This one here, we can make it all. Let's see these ones. I think we'll keep these as 4 marks for this, 4 marks for this. This one here is 6 marks. And this one is 5 marks. Press pause, give it a go if you haven't started yet, and press play when you're done. Alrighty, let's go through it now. Let's have a look at what we have here. Alright, so the first thing we got here is you can see we have to calculate the area. So we need to know the formula of the area, right? The formula for area is pi r squared. And the formula for circumference can be between 2, right? We have 2 possibilities. And that's going to be 2 pi r or pi times d. Those are 2 possibilities. So for this area here, it's going to be pi multiplied by 4 squared. And that's going to be 16 pi. For this one, 2 times pi times 4. If I use the first formula, it'll become 8 pi. Okay, we can put this on a calculator and let's see what we get. If you use pi as 3.14, you'll probably get a different answer. If you use pi from the calculator as it is, you'll get a different answer as well. for each of these. Okay. Give me 1 second. I'm just going to grab this calculator so slow. All right, I'm just going to go with 3.14 and multiply it by 16. We get 50.24 for this one. And don't forget that centimeters squared. Then we got 8 multiplied by 3.14, and that'll become 25.12, and this will be centimeters. Okay. The next one we have to calculate the area of the unshaded part, which is this entire region over here. So to do that, what we need to do is calculate the outside. We have to calculate the outside or the big area, and then we calculate the small area, and then we subtract it, right? So I'm going to write the area big will be pi times by 6 squared, because that's the big area's radius. And that'll come to 36 pi. Now it's useful to just leave it like this. If you just leave it like this, there's 36 pi. You can basically minus it in one go and then put it in the calculator only once instead of using a calculator twice. So the area, which is the small area, will equal pi times half of 8. Now what is half of 8? 4, right? That'll be 4 squared, because that's going to be the radius of this small circle. Remember the radius is 4 centimeters. That becomes 16 pi. And I can just minus the pi. It's like 36x minus 16x equals 20x, right? So the unshaded area is going to be given by 36 minus 16, and it becomes 20 pi. I'm using 3.14. Don't forget your answer will be different if you use a calculator and pi. I'm going to use 3.14. 20 times 3.14 comes to 62.8. Your answer should be very close, if not the same. And don't forget centimeters squared for this as well. Centimeters squared, and it's only centimeters squared. For the volume over here, the formula is pi r squared times height. So that's pi. Now my radius is actually 10 meters in total. My radius is 10 meters in total. So it's going to be 10 squared multiplied by height, which is 20. This will become 100 times 20, which is 2000. Put that on a calculator. Okay. 2000 multiplied by 3.14 comes to 6280. 6280 meters cubed. Don't forget radius is 10 over here. The surface area formula is two circles, remember, at the top and at the bottom. So 2 pi r squared. So this one over here and this one over here, plus 2 pi r h. Now r, the radius here is going to be 10. That'll be 10 squared plus 2 pi r multiplied by h. Now r is still 10, and my height is 20. This is going to become 100 times 2, which is 200 pi. And this here is actually this area and this area over here. Whereas this calculation is the area around the shape. We're going to plus that. That's 200 times 2, which is 400 pi, comes to 600 pi. So we take that and we put it in our calculator using 3.14. Again, I'm going to use that. It's 1886. No, 1884. 1884 meters squared because we're calculating area. For the last one here, we have to take a fraction of the whole. Now we don't know this angle. We don't know the angle of the sector. Now we know that this adds up to 360 degrees. So this is automatically going to become 360 minus 150. That's how we get this, 360 minus 150. That's that angle there. So what is 360 minus 150? 210. Because together it adds up to 360. So that's 210. Those two add up to 360. So the area here is going to be pi multiplied by radius, which is 8 squared, multiplied by the fraction of 210 over 360, because that will be the same as this over the entire circle. If I get that fraction, 210 over 360, then I'm done. So maybe I should write it first. I'll take 210 out of 360 degrees. That's the fraction of that. And multiplied by the entire area, which is pi times 8 squared. If you used 150, it would be calculating the outer area, which is not what we want. We want the inner area. So be careful. I'm now got 21 over 36. I can divide this by 3. I'll get 7 over 12. Divide by 3, divide by 30, divide by 30. I'll get 7 over 12. And then multiply that by 64 pi over 1. Canceling out this 12 and the 64, this will become 6 and this will be 32. So we end up, let's put it on a calculator now. 7 times 64 divided by 12. And then multiply it by 3.14. You should get 117 centimeters squared. 117.23 if you had 2 decimal places or 1 decimal place, centimeters squared. Like that. Let me just double check it on the calculator again. 7 times 64. Yeah. The perimeter is calculated by taking this length, which is 8 centimeters, plus this length, which is 8 centimeters, plus that length that's going all the way around. And that length is a fraction of the entire circumference. It's that part of the circumference. So it's 210 over 360 again, but this time we multiply it by the circumference formula and not the area formula, which is pi times d or 2 pi r. So 2 pi multiplied by 8. Yeah, putting that on a calculator becomes, so it's 8 plus 8 plus, and basically, yeah, we got 210. Let me get that first. 210 divided by 360 multiplied by 16 pi, or 3.14, comes to 29. This will come to 29.30, and then plus 16, because that's the other two sides, comes to 45.3. 45.3 centimeters, because it's a perimeter. It will be 45.3 centimeters for that. I'll just double check this calculation here, just to make sure that it's correct. Remember, 8 plus 8 is 16, right? So this part over here will be 16 centimeters. And this part at the bottom here, I can simplify this fraction again into 7 over 12, and then multiply it across there, right? So I'm going to do that. Yeah, 29.3 plus 16, 45.3. All right, the mark allocation for the first one here, substitution, solving, don't forget -1 if you didn't get the units. Substitution and solving, that gets you 4 marks in total. This one here, 4 marks as well. The big area, 1 mark, small area, 1 mark, knowing that you have to subtract them, 1 mark. The answer, 1 mark minus 1 if you got the unit wrong, or you didn't write the units perfectly. Don't worry about keeping track of your score, but for now, if you want to mark yours, you can mark it according to this. But just to give you a good idea of what to expect in a test situation, you have to provide some kind of working. Never just show answers, you lose that mark. So if you just show this answer without that, you only get 1 mark. You have to show working if it's 2 marks or more. If it's 1 mark, then you can just put one answer, it's fine. But if you got 2 or more marks, you have to show. I generally think that if you got 2 marks, put 1 line or 2 lines of working. If you've got 3 marks, put 2 or 3 lines of working. If you got 10 marks, put 9 or 10 lines of working, for example. This is a guideline. All right, the next one here, 6 marks for this one. The formula being correct and substitution. And then the next one, the formula being correct, substitution into this one, getting that entire formula correct. All right, I think substitution and calculation and then the final answer. For this one of your area, knowing that this is going to be pi r squared multiplied by the fraction. Your 1 mark for the fraction multiplied by the entire area calculated can get you 2 marks, maybe even 3 marks. Okay? Again, same thing over here. But here you would get extra mark because you got to add those 2 8s in there to get the entire perimeter. And then finally, that gets you 5 marks for that. I'll give you a second to just reflect on that and have a look. Okay. If you show you're working and your answer is wrong, you can get full marks for working, which means you can still get half of that entire exam. So let's say you answer 80% of every question in an entire exam. That means you get 80% for the exam. So generally, the answers only count for 1 mark. For those that didn't get to this question, let's just go through it anyway. In this question here, we asked to calculate the volume and the surface area. The first thing I'm going to do is calculate the volume. Now, this inside here has been removed. Okay, so that's been removed completely from that. All right, just switch it to full screen. So yeah, that's the question. Let's have a look at how we answer this one for volume, right? We need to calculate the big volume and subtract it from the small volume. And that'll always give me the volume in between, which is all the way around, right? Okay, so I'm going to write your volume big is equal to, the big volume is given by pi RH, right? Pi RH. Let me write down volume is equal to pi r squared h, pi r squared h for a cylinder. So this is going to be pi times. Now this radius here, you can see from here all the way across is 8 centimeters because it's half of 16. It'll be 8 squared. And h is 30. That doesn't change. This will come to 64, 8 squared times 30. And that's 1,920 pi. The volume of the small cylinder, working on the same basis, pi multiplied, but now we can see that this is 2 centimeters because it's half of 4. So 2 squared times the same height, 30. 4 times 3 is 12, 120 pi. And then we subtract those two, and that gets me the volume that I'm looking for, which is going to equal 1920 pi minus 120 pi, which is 1,800 pi. All right, let's go to surface area now. Surface area would be the entire surface area. I've got to minus this, and I've got to minus the inner area, and so I'm going to minus the two surface areas, right? So let's get the surface area of the big one. Would be given by pi r squared. Remember, surface area of a cylinder is given by 2 pi r squared plus pi rh. This is going to be 2 pi times the big one, right? This is the big one. 8 squared plus pi times 8, and the height is 30. So the big surface area is going to become 64 times 2 is 128 pi plus 240 pi. 368 pi becomes the big area. Then we've got the small area on the same basis, but this time 2 pi times 2 squared plus pi multiplied by 2 multiplied by 30 Just changing the radiuses. 4 times 2 is 8 pi. 2 times 30 is 60. So 68 pi gets me the small area, and therefore surface area, I'll just write the area. And remember, this is the inside area removed. Maybe there's something missing here. Let's think about it carefully. If I remove the inside area, that's also wrong, right? I should only be removing these two small little areas over here. Let's take it a step back. This number over here is 8 pi. That's going to be this area here at the top. That area there is 8 pi. And this area here at the bottom is also 8 pi, right? And the inner area on the inside is 60 pi. So what do I need to do? Look carefully. I need to keep one of them and remove one of them, and not simply add it. So what I'm going to do is I'm going to keep these separately from each other and just label it quickly for you to understand. This is going to be the small circle at the top. I'm just going to write here 2 times small circles. This one here is inner cylinder, right there, inner cylinder, all right, which is 60 pi. So I need to add that. Let's make a note of this. I need to add that area to that, but I need to subtract this one because that's the holes at the top and the bottom. So therefore, my final answer is actually going to be looking more like this. So the area is going to be given by 368 pi minus 8 pi, subtracting that, plus 60 pi. Minus 8 is 360, 360 plus 60 is 420, so 420 pi. Put that on the calculator. I'm going to go with 3.14 again. 420 times 3.14 will come to 1,318.8 centimeters squared surface area. This one over here, let's quickly get that as well. 1,800 times 3.14 will come to 5,652 centimeters cubed. The volume you subtract is nothing to add one there. All right, it's just the other one that you have to do. All right, and that's my answers for those two. I'll give you a second to take some notes, a minute or two to just understand it and digress it. All right.
In this lesson, we're going to talk about how to find the interquartile range, as well as the presence of any outliers. But let's take some notes first. So let's say we have a number line. On the left side, this is going to be the minimum value, and on the right side, the maximum value of the data. Now, the median of the data is the second quartile. This is basically the 50th percentile. The minimum will be at the 0th percentile, and the maximum is basically the 100th percentile. Now, Q1 is going to be the median of the lower half of the data. And Q3 is the median of the upper half of the data. And so that's how you can find the three quartiles. The interquartile range represents the middle 50% of the data. IQR is the difference between the third quartile and the first quartile. And so that's how you find it. By the way, Q1 represents the 25th percentile, and Q3 represents the 75th percentile. Now let's talk about the outliers. Sometimes you may have a data point that is either all the way to the right, that's very high, or to the left, that is very, very low. Now, here's what you need to do in order to find if a number is an outlier. The outliers will exist outside of this range. It's going to be outside of Q1 minus 1.5 times the IQR value to Q3 plus 1.5 times the IQR value. So if you have a number that's in the list and it's not in this range, it's outside of it, then that number is considered to be an outlier. And we're going to do some examples so that you can see how this process works, like how we can go about determining if a number is an outlier or not. So let's say if we have the numbers 5, 8, 15, 26, 10, 18, 3, 12, 6, 14, and 11. So let's go ahead and find the IQR value, and let's see if there's any outliers in this list. So what's our first step? What's the first thing that we need to do here? The first thing you want to do is you want to rewrite this and arrange the numbers in ascending order. So 3 is the lowest number. Next, we have 5, and then 6, and then after that is 8, 10, 11, and then it's 12, 14, 15, 18, and then 26. Now, the next thing you want to do is identify the median of the entire data set. So the median is basically the middle number. If we eliminate the first two numbers on both sides, and then follow that process until we get one number in the middle. So this is the median. So 11 is the second quartile. So what I'm going to do is, I'm going to draw a line here, and I'm going to put 11 below that line. So this is Q2. Our next step is to identify the median of the lower half of the data. So the middle number of these 5 numbers is 6. So let's put a line. And so 6 is going to be Q1, the first quartile. Now let's do the same thing on the right side. Let's identify the median in this area. So the middle number is 15. So 15 is the third quartile. When you think of the word quartile, I think of quarters. 4 quarters equal $1. And so the quartiles, they divide the data into 4 equal parts, as you can see here. Now at this point, we can calculate the IQR, the interquartile range. It's the difference between the third quartile and the first quartile. And so we see that the third quartile,
if you're going back to school, before you submit your essays,
15, and the first quartile is 6. So 15 minus 6 gives us 9. And that's how you can calculate the interquartile range. Now our next step is to determine if we have any outliers. So looking at the numbers in this list, do any one of these numbers stand out? Is there a number that appears not to belong to the rest of the pack? Now to me, 26 seems to be a little far out from all the other numbers. So is 26 an outlier? Let's find out. So what we're going to do is, we're going to plug our data into this interval, Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times the IQR value. So Q1 is 6, and the interquartile range is 9. Q3 is 15, and then it's going to be plus 1.5 times 9. 1.5 times 9, that's 13.5. So 6 minus 13.5 is negative 7.5. And then 15 plus 1.5 times 9, that's going to give us 28.5. Now, an outlier will be any number in this list of numbers that is not in this range, or that is outside of that range. So is 26 outside of this range? 26 is in this range. So therefore, 26 is not an outlier. Now, let's say if this was 29, then it would be an outlier. Let's try another example. So let's say we have the numbers 11, 31, 21, 19, 8, 54, 35, 26, 23, 13, 29, and 17. Go ahead and pause the video and try this example for yourself.
Alright guys, give it a go. See if you can find the interquartile range. Just the interquartile range. Try it. Press pause when you're done, press play.
Calculate the interquartile range and determine if we have any outliers in our data set. So let's begin by writing the numbers in increasing order. So we have 8, 11, and 13. So after 13, we have 17, 19, and 21. And then after that, we have 23, 26, and 29. And then the last three numbers are 31, 35, and 54. So we have a total of 12 numbers. Our first step is to calculate Q2, the second quartile, thus splitting the data into 2 equal parts. So if we eliminate the first 2 numbers on both sides, and then follow the pattern, notice that we have 2 numbers in the middle. So to calculate the second quartile, we need to take an average of those 2 numbers. So we can add them up and then divide by 2. 21 plus 23 is 44. 44 divided by 2 is 22. So this is the second quartile. Now we have 6 numbers on the left and 6 numbers on the right. So now we need to find the first quartile. So what is the median of these 6 numbers? If we eliminate these 2 and then those 2, we have 2 numbers in the middle. So we need to average those 2 numbers. That was weird. So we're going to split the lower half of the data into 2 equal parts, where we have 3 numbers on the left, 3 numbers on the right. So the average of 13 and 17 is going to be the middle number between those 2, which is 15. So 15 is the first quartile. Now to find Q3, we need to split the upper half of the data into 2 equal parts. In this case, 2 parts of 3s. So the average of 29 and 31 is 30. So 30 is going to be the third quartile, our Q3 value. Now once you have Q1 and Q3, you can now calculate the interquartile range. So it's going to be 30 minus 15, which is 15. And so this is our IQR value.
All right. Do you guys understand? Yeah? Is that good? Okay, interquartile range. Interquartile range. I'm going to give you a quick activity now. Give it a go, and then we're going to be jumping into a Kahoot to practice some interquartile range. Okay, some interquartile range. A quick revision activity so you can just make sure you've got it so that you can do well in the Kahoot. Let's have a look. Or we can just find some from here. All right, let's jump into some Excel. See if you can find the lower quartile for this one. Type your answer in. All right, I got 31.7. Did you arrange it from smallest to biggest? So let's do that first, right? 17, 31.7, 33, 34, 36, 40. First, you find the median, which is 33.5, halfway between those two. Then you look at the left-hand side and you find the median. This one is 31.7, and that's my lower quartile. Let's type it in there. All right, see if you can find the upper quartile for this one. The smallest number here is 13, 17, 53, 53, 80, 84.8, 93, and 97. If I count how many numbers I have here, I've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. So let's take out 4 from either side. This is going to be 53 plus 80 over 2. 66.5. And if I look at the upper quartile, it's going to be on this side over here. And I've got 1, 2, 3, 4 numbers, so it's going to be between those two numbers. 84.8 plus 93 divided by 2. Grab your calculator. 84.8 plus 93 divided by 2 comes to 88.9. And that's the upper quartile. Well done, you got it. Okay, now we're going to go on to the whiteboard quickly. And you're going to get several Kahoots coming through now. Okay, so you can join with the following Kahoot codes. All right, so here's the Kahoot codes coming through, which will probably be available for the next 3 days. The first code is 06008181. 4 players have already played it. You can try it and see if you can beat their scores if they weren't too low. The next one is, so this is interquartile range. The next one is going to be area of sectors. You can do it in either order. You can start anyone in either order. 0, 4, 7, 3, 9, 5, 6, 4. Choose which area you want to do. You don't have to do all. You can do it later as well, but you can try and finish them as much as you can. You should finish 1 or 2 within the next 9 minutes. So 0, 5, 5, 7, 3, 9, 4, 0. Volume of cylinders. Go to kahoot.it and put your name or nickname. Give it a go. See if you can beat yourself and whoever's there.